So let's have this problem. So to find the integral of exponential functions, and these are the formulas for the integral of exponential functions. So for the integral of a to the power u du, where a is a constant and must be greater than 1, so that's a to the power u over ln a, then plus c. Then for the integral of e to the power u du, so this is equal to e to the power u plus c. Then for this given, to evaluate now the integral, so using the u substitution, so we have a equals, so a is the base, that's 4. Then u equals, u is the exponent, so this is 6x. Then for du, or the derivative of u, so the derivative of 6x, this is 6. Then we need to put dx. Then since from the given, there is dx, and to solve for dx, so we need to divide both sides by 6 to solve for dx. So we have du over 6 equals dx. Then using now the u substitution, so we have the integral of 4, and 4 is equal to a, then to the power 6x, and 6x is equal to u. Then for dx, and dx is du over 6. Then we need to put this denominator 6 outside. So this becomes 1 over 6. Then the integral of a to the power u, then du. So we can use now this formula. So this is equal to 1 over 6 then times a to the power u. So we have a to the power u then over ln a, then plus c. Then replace now the values for a and u. So this is 1 over 6 then times a is 4. So this is 4 to the power u, and u is 6x then over ln a is 4, then plus c. Then to simplify, so multiply. So this is 4 to the power 6x then over multiply. So this is 6 times ln 4 plus c. Then for this given, so to evaluate now the integral, so a is the base, this is 7. Then u is negative 3x plus 4. Then du, so the derivative of u, since the derivative of negative 3x, this is negative 3. The derivative of a constant, this one is 0. So du is negative 3, then we need to add dx. Then to solve for dx, so divide both sides by negative 3. So we have du over negative 3 equals dx. Then using now the u substitution, so we have now the integral of a to the power u. Then for dx is equal to du over negative 3. Then we need to put this denominator negative 3 outside. So we have negative 1/3 or 1 over 3, then the integral of a to the power u, then the du. Then we can use now this formula. So this becomes negative 1 over 3, then over a to the power u. So since a is equal to 7 and u is negative 3x plus 4 over ln a, and a is 7, then plus c. Then to simplify, so this is equal to negative 7 to the power negative 3x plus 4, then over, so multiply. So we have 3 times ln 7, then plus c. Then for this given, so first, we need to bring up this denominator. So this becomes the integral of 5. So the exponent becomes negative, then the dx. So using now the u substitution, so a is the constant or the base, u is negative 4x, then du. So derivative of negative 4x, that's negative 4, then dx. And to solve for dx, so divide both sides by negative 4. So we have du over negative 4 equals dx. Then this becomes, so from this equation, so we have the integral of a to the power u, and dx is du over negative 4. Then put this denominator negative 4 outside. So this becomes negative 1/4. Then the integral of a to the power u du. So we can use now this formula. So this becomes negative 1/4, then times a to the power u. So a is 5 and u is negative 4x, then over ln a is 5, then plus c. Then to simplify, so this becomes negative, so multiply. So we have 5 to the power negative 4x, then over 4 times ln 5, then plus c. Then if you want to make this exponent positive, so just bring down. So this becomes negative 1, then over 4 times 5 to the power 4x, then times ln 5, then plus c. Then for this given, so to find the derivative, since this one is e, so we have now u equals the exponent, that's 5x squared plus 1, then du, so the derivative of u, so the derivative of 5x squared, this is 10x, and the derivative of a constant, this one is 0. So du is 10x, then dx. Then since we have this x dx, so to solve for x dx, divide both sides by 10. So this becomes du over 10 equals x dx. Then to rewrite now this integral, so we have the integral of e, then this 5x squared plus 1, so that's equal to u, and this x dx, that's equal to du over 10. Then we need to put this denominator 10 outside, so this is 1 over 10, then the integral of e to the power u du. So using now this formula, so we have 1 over 10, then times. So since the integral of e to the power u du, that's equal to e, to the power u, then plus c, then substitute now the value of u. So this is 1 over 10, then times e to the power u, and u is 5x squared plus 1, then plus c. Then for this given, so first we need to rewrite this radical in exponential form. So this is equal to the integral of e to the power 4x, and this root becomes the denominator. Then we have the dx. Then since this one is e, so we have u is equal to 4x over 3, then du, or the derivative of u. So for the derivative of 4x over 3, since this 4x over 3, we can write this one as 4 over 3x. And to find the derivative, so we just need to drop this x. So this becomes 4 over 3, then the dx. Then to solve for dx, so divide both sides by 4 over 3. So therefore, du over 4 over 3 equals dx. Then for this du over 4 over 3, we just need to take the reciprocal of this 4 over 3. So this becomes 3 du over 4 equals dx. So we can use now the u substitution. So from this equation, so we have the integral of e to the power u, and dx is equal to 3 du over 4. Then we need to put this 3 over 4 outside. So this becomes 3 over 4, then the integral of e to the power u du. So we can use now the formula. So that's equal to e to the power u plus c. So we have 3 over 4 times e to the power u plus c. Then substitute now the value of u. So this becomes 3 over 4 times e to the power 4x over 3 plus c. Then for this given, so this one is a constant, so this is a, so that's 2. Then u, the exponent, so we have cosine 6x, then du, so the derivative of u, or the derivative of cosine, that's negative sine 6x times the derivative of 6x, that's 6. So this is equal to negative 6 sine 6x, then the dx. Since we have the sine 6x dx, so therefore we need to divide both sides by negative 6. So we have du over negative 6 equals sine 6x, then the dx. So we can use now the u substitution. So this becomes the integral of a to the power u, and sine 6x dx, that's du over negative 6. So we need to put now this negative 6 outside. So this becomes negative 1 over 6, then the integral of a to the power u du. Then we can use now this formula. So we have negative 1 over 6 then times a to the power u, and a is 2 over u cosine 6x then over ln a or ln 2 then plus c. Then to simplify, so this becomes negative 2 to the power cosine 6x then over multiply. So this is 6 then ln 2 plus c. Then for this given, so since e, so we have u, the exponent, so that's tangent 2x minus 5, and du, so the derivative of tangent, this is secant squared 2x minus 5 times the derivative of 2x minus 5, this is 2, or du is equal to 2 secant squared 2x minus 5, then the dx, since we have secant squared 2x minus 5 dx, so we need to divide both sides by 2. So therefore, du over 2 is equal to secant squared 2x minus 5 dx. So using now the u substitution, so this is equal to the integral of e to the power u and secant squared 2x minus 5 dx. So that's equal to du over 2. Then we need to put this denominator to outside. So we have 1/2. Then the integral of e to the power u du. So from this formula, so this becomes 1/2. Then e to the power u, and u is tangent 2x minus 5, then plus c. Then for this given, so first we need to expand this equation. So using the shortcut method, or you can use the FOIL method for this equation, and using the shortcut method, the SMS, so we have the integral s, the square of the first term, so this is e to the power 2x, then m, so we need to multiply these three numbers, so this is 2 times negative e to the power negative x times e to the power x, so this is negative 2 e to the power x and e to the power negative x, then plus the square of the last term, so this is e to the power negative 2x, then the dx. So again, you can solve this or expand this equation using the FOIL method. So you just need to rewrite this e to the power x minus e to the power negative x twice. So e to the power x minus e to the power negative x, then apply the FOIL method. So to expand, then to simplify or to integrate every terms. So this becomes the integral of e to the power 2x dx. Then minus, we need to put this constant to outside times the integral. So for this e to the power x times e to the power negative x. So take note, if we have x to the power 2 times x to the power negative 2, so for multiplication, we need to add these exponents. So this becomes x to the power 2 plus negative 2, or this is x to the power 0 And if the exponent is 0, so this is equal to 1. So therefore, this x minus x, this becomes e to the power 0. This is equal to 1. So since this one is equal to 1, so therefore, negative 2, then the integral of dx or 1 dx, then plus for this term, so the integral of e to the power negative 2x, then the dx. Then to evaluate now the integral for this term, so for this term, u is 2x and du is 2 dx. So divide both sides by 2. So we have du over 2 equals dx. And for this term, u is negative 2x, du is negative 2 dx. So we have now du over negative 2. So divide both sides by negative 2 equals dx. Then to substitute now the values. So for this term, so we have the integral of e to the power u, then dx is du over 2, then minus 2 times the integral of dx, then plus the integral for this term, e to the power u, then for dx, du over negative 2. Then we need to put this denominator to outside, so this becomes 1/2, then the integral of e to the power u du, then minus 2, then the integral of dx, and put this negative 2 denominator outside, so this becomes negative 1 over 2, then the integral of e to the power u du. So we can use now this formula. So we have 1/2, then e to the power u. So for this term, u is 2x, then minus, so we have 2, and take note that the integral of dx, that's x, then minus, so 1/2, then e to the power u, and for this term, u is negative 2x, then plus c.